Hi, my name is Dave Shanley, and this is a quick guide to creating an event-driven or pub/sub service and a client that is defined by an Async API contract using Go. If you'd like to learn more about Async API, head over to AsyncAPI.com and find out more about the standard and the power that it provides. Moving forward, I'm going to assume that you already know what Async API is and that you want to use it in your Golang applications. We're going to create a microservice that exposes both publish and subscribe Async API endpoints. We will publish requests to one channel and listen for responses on another. We're going to create a terrible joke service. It will listen for an incoming joke request on a specific channel and then publish a joke response to a different outbound channel. Let's take a look at the Async API contract. We ask for a joke by publishing a joke request to pub/q/joke-service and then listen for a response on q/joke-service. Let's take a look at the definition of a joke response message that is broadcast. We can see that it's composed of two elements, properties defined by a transport response and a payload property consisting of a joke response. Our joke object is pretty simple, with only three properties. ID represents the joke ID returned by the source API. The joke is the actual joke that comes back, which is a string value, and status, which is an HTTP code that's produced by the source API. We're actually just passing this object straight through from the source API that we use to get our jokes. This tutorial uses Plank to provide all of the socket, message broker, boilerplate, and glue code that you typically need to implement Async API services. Plank is actually part of Transport, which operates as an async application framework, if you will. Now, Transport will wrap any response emitted by a service with these properties and make the service response available via the payload value. The payload can be anything. It can be an object, a primitive, or a string, anything you can think of. So let's start by importing Transport into a new project. Let's create the directory in which our service will live. We'll call it, I don't know, services? Now we can actually create our new joke service. So create a new file named joke_service.go. First, we need to define a constant that sets the event bus channel that our service will operate over. We're going to call it joke service channel. Next, we can define our joke struct. It represents what is returned by our API. The properties in it include an ID, a joke value, and an HTTP status code. The joke service struct has no properties of its own, and we create a new instance of it by using the new joke service function. We also use the init function, which is a lifecycle method to automatically set outbound headers that are commonly required for JSON-based applications. Next, we implement the handle service request method. This method should act as a delegator, deciding where to send each request based on the request property that comes in to the handler. Now, the request property should match the operation ID of the Async API contract. We call this the command. We're only interested in one operation in this service, which is get-joke. So let's send our request over to a handler method. We're actually going to do the business logic for calling a joke, and we'll call it getJoke. And we can let a default handler handle anything else that comes in that isn't a get-joke command. A getJoke will use a simple REST service that's already built into the core of Transport. The REST service makes it super easy to call an API to actually go and get our joke. We configure our REST service call by providing a service request, a success handler, and a failure handler. The REST service request only needs a few properties to be helpful. These are the URI that we want to call, the HTTP method, and any headers that we need. Now, using reflection in our REST service, we set the response type as a joke type, so the REST service knows how to deal with the incoming response from the API. And then we provide a success and error handler for the REST service call. Now, there isn't much to do with a successful response other than just pass the joke object back to the consumer. And the same can be said for our error handler. We're just going to create an error response and send it back to our consumer if anything goes wrong with the API call. Whoops, a small typo there in payload. I'll come back and clean it up. Now, if we also want to expose this Async API pub/sub service over a RESTful transport using something like OpenAPI, Plank provides us with this really helpful lifecycle hook called getRESTBridgeConfig. Plank makes it easy to bridge synchronous and asynchronous applications together by allowing services to provide a REST bridge config. The config tells Plank the service's channel, the path to use, the HTTP request type, and the options, essentially converting everything to an asynchronous event call. The bridge connects REST endpoints with bus calls, and we tell Plank how to call our joke service for each of the endpoints that we want to define. So all that's left is to implement some of the other lifecycle events. Plank requires them, but we don't really need them in this tutorial. On-server shutdown is used to end long-running tasks the service may be operating. We're not doing that in this service, so there's nothing that we really need to do here. And lastly, on-service ready is used to set up the service before making it available. We don't set anything up in this service, so we can simply return a prefied Boolean channel here, which allows the service to be made available immediately. Our service is ready. Now we need to create an instance of Plank, load up our service, and try it out. So let's start by creating a directory called server. Obvious, I know. Next, we're going to create a file called server.go. Bet you guessed it. Let's create a new instance of Plank by using a default Plank server configuration running on localhost on port 30080. We then register the joke service with Plank by using our new joke service function, and we provide the joke service channel constant that our service also defines. Lastly, we create an os.signalChan and we pass it to Plank to start things up. This is used by Plank to capture interrupts and things like that, like Control-C, etc. Now we can boot up Plank and see our terrible joke service. The Plank boot screen should appear, and you can see that lovely Plank. And something like the following should be seen in the console. So let's fire up curl and try it out. Pretty neat. But let's go deeper and create a client to connect to our local instance of Plank and query our service using pub/sub. I want to take a second to explain the essentials of transport and how it works so that the next bit makes sense. Transport is an application event bus that operates as a singleton inside an application. Components or actors can message each other asynchronously using the bus without needing to have a reference to each other. The bus allows the creation of universally available channels that all components in the application have access to. A key benefit to this design is that it makes it easy to build decoupled, event-driven application architectures. A feature of Transport for Go is that it has the ability to bridge instances together without needing a third-party message broker. It has a micro broker built in. Transport can connect over TCP or WebSocket, and it uses Stomp as the wire protocol. In fact, it can connect to any message broker out of the box that supports Stomp. There is a concept of marking channels as galactic in Transport. And this essentially means that an application bus channel is mapped to a broker destination. Under the hood, Transport automatically subscribes to that broker destination and then relays any inbound messages to that local application event bus channel. Marking channels as local will unsubscribe from the broker destination. Okay, I'm sorry. Let's get back to the tutorial. Let's create a new file called, can you guess it? Client.go. First, we create a broker connector configuration that connects to the local instance of Plank that's running on port 30080. Let's configure our WebSocket connection by setting the path to /ws and disabling TLS. Next, we get a reference to transport and the channel manager that it provides. Using the bus, we connect to our local instance of Plank, and we create a local channel on our application bus that we then bridge to our joke service subscription destination. We create a stream handler named joke sub handler using listen once. Then we use mark channel as galactic to bridge our local channel to /q/joke-service. And we don't want the application to exit before a response has a chance to come in, so we can use a wait group. Next, we define success and failure functions for our stream handler. Both these functions accept a model.message type. In our success handler, we can extract our joke by using the cast payload to type method available on our inbound message. We can log out the joke property of our response to the console and then inform the wait group that we're done. Now, our subcode is complete. We can write the pub code. So let's create a model.request object and set the request property to be the get-joke operation ID or command that our joke service is looking for. Using our connection, we can fire the model.request object off to our published destination, which is /pub/q/joke-service. Once published, our wait group will block the application from completing until our joke response actually comes back in. To clean things up, we can mark our channel as local, which will unsubscribe from our server cleanly and then disconnect. Now we can run our client and enjoy a terrible joke. And that's it! You're up and running with your own AsyncAPI Nano platform. If you enjoyed this video, hit subscribe, leave a comment, and then head over to quobix.com for more adventures in code. Thanks for watching. Until next time.